All right, so I'm Davide, and together with Guy, we are the main maintainers of LiveCodeLab 2.0, which is a live coding environment for the web. And I'm going to give just a 1 second demo of what live coding on the web is. So you have your web browser, and you can download it and use compile LiveCodeLab just from GitHub. Just take the most recent master where kind of all these examples will work. So you can type something. Okay, you can type something like box, and this happens. So I just literally type BOX, and that would work. And you have other primitives. You have boxes and tags and a few others. But we won't go. And we won't go into the complete API. We will actually talk more about the functional aspects and the language aspects. But before that, we just want to mention the projects that have been influencing LiveCodeLab the most. We took a lot of the API ideas, stuff like box and rotate. It's all really coming from processing. We've seen a demo by Jonathan Brodsky called JSaxes using WebGL, and it was straight JavaScript using WebGL. And it was quite a few years ago, and that told us that WebGL and web can work for live coding. Obviously, Fluxus greatly influential. Fluxus kind of different slant of accent or accent, which was very interesting from an artistic point of view, as it was from DJs to DJs, really crafted those visuals, very beautiful. So for what we did, what we chose to take as core values was learnability and usability. And that resulted in a few decisions that we made to have to kind of constrain our project to have simple syntax, simple comments, keywords, such as box you've seen. Usually can go for more fancy descriptions and names for those kind of primitives, but we chose simple ones. We cater for mostly for short programs, and not necessarily interesting into multi-pages programs, as we do kind of live coding. And to kind of value immediate feedback and quick interaction. So you've seen that you don't have to compile or run specific parts of code, everything is type and run. So you've seen the main demo, this starting kind of typing demo saying box, which draws a box. But there's something already kind of telling about it, is that, there's nothing special in the syntax to tell that this is a function invocation. There is no parentheses. And so considering that it's in the browser, so everything ends up in JavaScript, there was some fiddling involved in that. Both me and Guy will talk about this in the next slides. And yeah, obviously, there is such a thing as a function invocation without arguments. Behind the scenes, there are some defaults that are being used. This just goes to say that a starter, a kid, doesn't need to know that parentheses means something else other than priorities of things. So there's no such concept as the function invocation is supposed to use. This is not the only language, but this happens. Ruby, for example, does some of that as well. We freely use literals, like in abundance. We expose 140 CSS color literals, so you can go crazy with all kinds of colors. You get red, you got lemon, chiffon, all kinds of colors you can want. Also, we make use of indentation to avoid curly braces and blocks, and guys will talk more about that. But to us, this is one of those things that we think people pick up from recipes and shopping lists. It's somewhat kind of built in our culture, our visual system, that indentation involves some kind of grouping. So, in fact, this is even more straightforward than to say what's the meaning of the equal sign. When that's assignment, it's kind of not obvious. Like indentation is more obvious than that. So we kind of gladly embrace that. Also, guys, we talk again better and more about that indentation as a way to define the scope of graphic state changes. We see more examples, but in this case, just suffice to say that it's so as you see, there is one rotation that is applied to the indented bits, and then the cylinder kind of sitting there doing nothing, not affected by the rotation. And more examples will come later. Also, we provide several shorthands for state changes that we think are more natural in language. And by more natural, we like to think shorter in particular. I think this is how we interpret natural. There are other ways to interpret how you would code to something natural. Other languages make other choices, but for us, kind of shorter is particularly meaningful. So you can say red box instead of fill red box. And you would usually, if you're familiar with processing, you would say fill red or fill color, and then the primitive. But we can get away with some shortcuts. And multiple comments can be generally in lines. So whenever you have a block, you can kind of put that block in line, and the meaning is the same. So in this case, rotate red box. The rotation only affects the red box. The red only affects the box. So it's kind of like that way. And then we come to the kind of more meaty. There are more examples in the paper, but we come to the meaty part, the more functional parts. We use the kind of angle brackets for inline anonymous functions. And you see this example kind of flickers between a box and a cylinder. And it's kind of handy to have this notation where you can define two anonymous functions just on the fly, like that. And they appear right here, they get past A and B, they get run here, A and B. Again, very short, I think it's kind of cool. Just as a note, how that kind of allows users to invent their own DSLs quite easily. I can define above to be a movement, up or down, and then I can see box above all, above that. So I can still leave things to kind of compose like that. Perhaps okay, oftentimes okay, cool. Well, it works. Sometimes pasting between PDF, it kind of goes weird stuff with symbols and dashes and minuses and commas and stuff like that. Anyways. Moving on, and this is another one, flashing. So in that case, there is a random thing. So coin toss here, and we use scale 0 so that stuff disappears when you do scale 0. So you can do flashing ball, and that does what you mean. It does. It causes the ball to flash. All right. So there is a little bit of behind the curtains of how it works. Even the paper doesn't go into the full details of how it works. There are two different implementations. But basically, one of them, the guys can talk about the other one, we transform this into CoffeeScript. And we just follow the nested closure pattern pretty much, where this becomes rotate. And the rotate is past the function, fill red, and fill red is past the function, the box. Each function does what it's supposed to do, and plus invokes the function that it passes an argument. So in this case, rotate changes the matrix. Fill red changes the color state, the box is invoked, and then going back as the kind of call comes back, you undo those changes because they're kind of scoped just with the line. Right? That makes sense. I'm just going to highlight a few problems that we know we have. We didn't just highlight them quickly and then pass over to the high. So the current transformation to CoffeeScript are based on partial parse stuff using one of the two implementations. You could use regexes to do that. We know that nesting is not a strong way. Regexes don't do nesting well at all, and so I mean, you can imagine what happens when you nest stuff badly. You need to do some code wrong to make stuff better. But anyways, Guy, come to the rescue. With the next slide. Some transformation depends on the actual literals that you use. For example, all the colors actually have, you can't just reassign red to be something else. Expect the same tricks to work out. You can say rotate red box if you substitute red, but not if you rename red. Right? So that's no, that's not ideal. Maybe fix it wrong. Some simple code, and by some subjective definition of code, still has to be explained. We could interpret. We can do. You can say 2 times rotate box. What do you expect to happen? You expect 2 boxes to be drawn and to be rotated, both of them, and to be kind of visually distinct. But actually, they're not. They're rotated by the same amounts with exactly overlap each other. Right? We have no way to make it work out. Perhaps would be more intuitive and still have a language that kind of makes sense. Semantics that makes sense. There is a bit of a workaround to that. Perhaps if there are questions, we can show that. And then, if you venture yourself into the actual functional bits and you start trafficking in functions, it turns out that you have to know a little bit how these transformations happen. The use of the curly brackets, for example, you see that here. You're saying something, but by something you mean do draw a cylinder, and you pass that here, rotate field red something, and that does that kind of draws a rotating red cylinder. So that would have you kind of to believe, well, I can use just angle brackets, and some kind of pixie dust, magic dust, and not really without the values and expressions that you don't need that. And to us, it makes entire sense. Whether that makes sense to kids learning this or to newcom. And in fact, we have kind of 3 types of different assignments, and you can start, if you really start tracking functions like that. Actually, there are subtle differences between these 2 examples, for example. Again, perhaps left for the questions, but this one, you can chain, that means you can chain more functions afterwards. You can say, so you have rotate field red tag here, and you can add the scale of it. You can say 2, and then it's a big cylinder. You can chain more, say, primitives. And in this case, you can't. Unless you, of course, to do manually some of the work that the translator obviously is meant to do. So I hope this is the case for training.
So as Davide mentioned, the current parser implementation uses regular expressions to rewrite a lot of the code and pass it through the CoffeeScript compiler, which is slightly less than ideal. So the sort of large chunk of what I've been doing with LiveCodeLab for a while is to actually give it proper grammar, preprocessor, parser interpreter. We've actually got sort of fairly far along with that work implementation, which is not currently live on the site. It's sitting slightly unloved in a branch on GitHub as we walk the best code. So the sort of the major reason for doing this is because it just makes it a lot easier to actually handle the features we want and to continue keeping the code sort of internally simple whilst we try and keep sort of external language simple. As far as I can tell, the biggest thing is just there's no more extra expressions, which massively makes maintainability better. So what I'll do is I'll talk a little bit more in depth about sort of the features that sort of moving to the new language and we can start fleshing out a bit more, sort of slightly more functional aspects of those in some cases. Hopefully just show where we can sort of continue to extend by the code now. So as Davide mentioned, block scoping is sort of one of the things that we've started using more. So this actually works for more than just the matrix transformations. It works for color changes. We've also got, you saw Davide mention the loops at one point. It's actually used similarly for loops and so on, so you can vary the indent code. Yeah, so, I mean, simple, for example, here. So in this case, not only is the rotate scope to the box, but also the fill on the box, which is just scope there. Issues with regular expression parser, obviously dealing with more and more complex nested stuff become really, really difficult. As soon as you've got a reasonable grammar, a lot of this stuff becomes pretty easy, which is really nice. And this makes it much easier for us to sort of extend what's happening and so on. Internally, really all that's happening here is it's still nested functions. You know, JavaScript is handling a lot of the heavy lifting for us, and once we've sort of translated into our AST, then JavaScript's going to deal with most of this. But if I, for example, oh yeah, so just clicking on loops. What we've actually got here is, so we're rotating around. The X is just an incremental counter. We're rotating each box by a fixed amount. Fill it with red, box. So it's just nice now that we have this proper grammar to be able to not have to worry that we're going to break straight away. Yeah. So the loops again, we just have translation down to a JavaScript function, and then that's iterated. Yeah. So, I mean, these are sort of the main primitives we use when we're talking live. It's quite simple to actually just string together reasonably interesting things. It's actually not that much code. So, yeah, so it's slightly more complex. Yeah, so here again, iterating through loops, multiple loops, counters and then. And so yeah, I mean, this is when we talk about trying to keep things very simple. You know, this is a big part of it, being able to write what we hope is fairly understandable code, very little syntax, and actually have some quite interesting features come out. Of course, the tricky part of this is not having parentheses, having block indentation. There is still a certain amount of pre-processing that goes into it. Yeah. So one of the issues I started running into, having never had to implement proper grammars and parsing before, is discovering that it's all very well and good trying to create your sort of your grammar and have it be simple. Indentation is really, really not good for doing that. Suddenly things get much more complex, and so you have to start adding in still more pre-processing for that. We have been more along the lines. There are ways to hopefully simplify this, which I'll talk about in a little bit. But yeah, it was something that trial by fire, trying to actually get things working the first time around, having got it connected before. But one of the things we realised was it was still very important for us to not have parentheses, not have braces, because from a usability point of view, we just feel that you want to do this as max possible. This brings us somewhat on to the type system. So there is actually a very rudimentary type system. Really, this is just trying to it shapes matrix transformations and star transformations, whereby the parser interpreter actually has some idea idea of this, and you can use this to better help it work out what's going on. Basically, it really comes through as in the inline. So it is embedded in the grammar. Unfortunately, at the moment, there's very little sort of error checking to do with the type system. So you will get errors for it, but it could give better feedback to the user. This is something that we want to step in. Yeah, for inlining, so yeah, I mean, this is really where the process will start becoming useful, and the parsing can start picking apart the matrix translations, which are the style translations, and that's based on type system. It's something that we want to continue extending for a matter of time. Question?
Is one of the boxes of balls supposed to be the other?
Box? Yes.
Right.
Yes, it is. And so, like I said, this directly translates to indented box, and primarily that's what the type system at the moment is used for. Yeah, so I mean, the two sort of main areas that we want to continue improving this, and primarily that's to do with the type system. For a start, I don't think it's necessary to have this full grammar describe everything in the preprocessor. We think actually giving the parts of better understanding of the types involved, actually you can start doing away with a lot of this and really simplify what's actually happening with the language and how we're parsing it. Requires a lot more sitting down and getting my parsing knowledge up to scratch, but I sort of think that's one of the places we can go. The other is quite like to improve the inline and try and make it more readable. Again, simplifying the sort of end user experience, having it easier for people to sort of code that feels more like written English. That's sort of the area that we actually want to work on. At this point, it's the end of the slides. Hopefully, to give forward to questions from the floor.
Yes, I have a question about the treatment of time in the system, because if I understood correctly, you have a sort of implicit time argument. So when you write rotate 0, for example, that's just the identity function, nothing happens, right?
Yeah.
And rotate 1 will be a fixed
So,
rotation. And if you write just rotate, it will be.
do you want to take this?
Yeah, we thought to make it dynamic that way, that if you use no arguments, then we say, well, we just animate, or something, we give you some meaningful animation, and as soon as you nail down a specific value, then
Yeah.
we obey that. And behind the scenes, that just tied into the time, I mean, not to the frame count. We can tie implicitly stuff to either the frame count or the time.
Yeah, but it becomes basically a function of time, right?
Yes.
And animation.
So, in fact, one of the things that we have tried to gloss over somewhat is the way that animation actually happens with the LiveCodeLab. The program that you've written here is actually executed every frame. So there is no state, or the user has no state between frames. This causes some issues in the way that we've had to implement things. But from the user perspective, it means that you don't have to worry about, oh, what's this variable going to do next time? It only happens within a frame. So the only variable that actually changes is the time variable. Yeah, so that's the nice thing about this, users don't worry. And then what we're doing, if we actually remove the two here, rotate is still being called as a function, but it is defaulting values based off time. So then you do get rotation. And again, it was we chose to do this purely because as a user, it's nice to be able to type in rotate box and you get a rotating box. You don't have to worry about what variables I call. When you're teaching 5-year-olds to do this, they pick it up much quicker if they need to get results.
Yeah, a very quick follow-up question. Because the time parameter is implicit, there would be no way of accelerating or slowing down time, right? Could you change the speed of the animation? Exactly. Tim.
Yeah, but no, there is less direct control over time. We should also point out, LiveCodeLab does do audio. We have patterns. The audio system, you can give it a BPM, have
So some of the first part of the presentation, you talked implicitly about sequential composition, because this and then that. I don't see why you need that. I mean, you're doing that just for presentation purposes. These are just declarative descriptions of some animation, right? And there's an implicit binary operator between those two rotating boxes of one slot on top of another, right? One on the front of another. So you don't need the semicolon, right?
No.
So I mean, you can think about a semicolon. There is no semicolon.
No, essentially, jumping in.
Yeah, we try not to use semicolons at all.
Yeah, I mean, by the actual syntax, when you talk about it, I mean, I forget the precise words that you said, but you said it does this and then it does that.
Yes, well, from my point of view, I mean, it's still, rotate goes first, it sets the matrix, then calls box, box throws itself, then when the call comes back, rotate unsets the matrix. That's what I meant to say, but
So, do you mean in sort of the grand scheme of things, in so much as, because this is happening every frame, it's not rotating this box, then rotating this box, it's merely describing, we have two boxes over the top of each other, which in this frame, they're rotating this
So
fashion.
the frame at time t is a box rotated this much underneath.
Yeah, so any individual frame is essentially a static thing, and it is just, as we pointed out, it's a function of time.
So I think that would also, with my Haskell hat on, I don't understand why you need the distinction between functions and function application. That's too. I would have thought at the
Only
moment.
because the parser and technology behind it is not especially advanced, but it helps us think about it in better terms. Yes, there are ways we can improve this and make it sort of more functional behind the scenes, but
But the front end user interface about what you type in a browser is a different question.
Oh yeah, sorry, go for it,
I have a question about time. What is how I define what is the increment? How is it dependent on just the seconds?
I think it's milliseconds since the start of the session or something like that, yes.
So it's just a...
So it's fixed and it's independent.
Yeah, correct. Yeah, it's independent of the frame rate. You just get the milliseconds you're at, and so it's the box should appear to have the same speed, even if your laptop is slow, even though it's not moving.
And so if we write the random flashing, it goes random each time incremented?
No, that goes random every time the frame is yes.
Yeah.
But yeah, time is purely just milliseconds. It increases and JavaScript handles us not worrying about overflows.
The way to see that would be to have purely noise based on time, and then that would be kind of frame independent, that would be time independent. And if we had the random that was tied into the time, but now it's kind of...
Sorry.
The compiler implemented in JavaScript and random decline.
So compilation happens whenever you change the code, and so essentially at that point it will recompile, and then either, depending on the implementation, you have your chunk of JavaScript which gets evaluated by the browser, or you have your AST which gets invoked. But yeah, so compilation happens at every change. There's some code around that to handle compilation errors. So once a program has been running for a certain amount of time, it will keep track of the last word of the program. If you have an error in the code, so if you're halfway through typing in a primitive, so that doesn't exist, if an error, it will fall back to the previously working version. And that's how we don't have to worry so much about sort of user seeing errors and if something breaks. It can still happen really easily, but a lot of the sort of issues with the aggressive recompilation every time you change are mitigated. I think that's us out of time.
One more quick question.
Sorry.
And then a question it possible to define something that if we do either like box or ball, is it going to switch randomly between them, or is it chooses once?
It will interpret every frame,
Yeah.
and so it will flip between them. So if there are more questions we're about all day with form this evening, come grab us and tell us how awful JavaScript is to work with. Cool. Thank you very much.